Chalo, we'll start the class, please. Ready? Good evening, beta. Let's start the class, please. Chahil, good evening. Come on, let's start the class. Come fast, come fast. Go from down and just start. We are going to start because last class we were discussing about momentum and we were discussing about some of the most important part. Let's see what and all we can do in this class. Down, go. Fine, let's start. Ish. Good evening, everyone. Now listen, what we are going to do here in this class, first we are going to understand some of the most important aspects what we have already studied. Okay, so we have studied about one very important thing. We have discussed about inertia. Inertia is the incapability of a body to change its state of rest or motion until and unless an external force is applied on it. So today we are going to do some most of the technical works. Okay. So in the technicalities, sir, please stop playing. Can we start the class, please? Okay. Now need to ask some of the questions what we have done in the previous class. Are you ready for it? Come on, say. Children, are you ready for it? Then we are going to solve some of the most important questions today. Last class, we were discussing about inertia in direction. Some of the questions were left. So inertia of direction, some questions were left. Deva, ready for it? Now come on, start answering this question. Inertia of rest, inertia of motion we have done. Now inertia of direction. Okay, good evening, beta. Good evening. Good evening. Inertia of directions. Today we are going to discuss about inertia of directions. Let's start inertia of directions. Okay. So somebody will be asking you about inertia of direction. What and all answer you are going to give about inertia of direction? Now, when a car is taking a turn, continuously means if it is exactly taking turns, that time what it is considered as? It is considered as inertia of direction. Okay. Now, next important point, if somebody will be asking to you that, I will be just when the car will take turn, I will go left side or right side, front or back. Which direction I will be turning towards? Which direction I will be turning towards if a car is exactly rotating? If a car is exactly turning and direction is turned, that time which direction the person will be moving? Which direction the person will be moving? Come on, say the answer, please. Say the answer, please. The direction, which direction the car will be moving? Hi, sir. How are you? Surinder Kumar. Subender Kumar. Bhavya, good evening. Beta. If the direction is this side, the car will be you will be going like this. If the direction will be this, you will be going this. All opposite direction. That is called as direction. Tanisha, my question was ki if a body, just understand this one, ki if a body is exactly at rest and it is very nicely inside a car, and then the car is taking turn. The car is in a very high speed and the car is taking left turn or right turn. Where you will be going when the car is taking a left turn? You will be bending forward, backward, left or right. When a car is taking left turn, where will be you? What will be your movement? What will be your movement? What will be your movement? Huh? Say first. See, You need to understand this one ki whenever you will be exactly the answer that the online student have understood the answer, offline children only are having problem. You see, understand first ki when you are exactly in a car and the car is heading towards right side, you will move towards left side, and when you will be exactly left side, the car will be exactly moving towards right side. So that is called as inertia of direction. That is considered as what? Inertia of direction. Now we are going to discuss some other important point. Now you need to answer me this question. I'm just asking you this one. Ki, when you are exactly tying a stone in a thread, and the stone will be exactly the thread you are rotating like this. So when the good evening beta, good evening. So what you are doing is you are exactly tying a stone on a thread, and after that what you are doing is you are rotating the stone like this. Okay, the thread will be exactly, you are doing like this, the thread will be letting the stone go like this. Let's see this one. So here the person is exactly standing like this, holding the stone, and exactly the stone will be, it will be like rotating like this, correct na? So the stone is here and the stone is exactly rotating in a specific direction. So after some time what will happen? If somebody will ask you, after some time what will happen, if the stone will come out of the thread, in which direction it will move? What will be the direction of motion of the stone once the stone will untie itself from the rope? Can anybody type and say? Please come on, say this one, beta. Huh? Can anybody say this? What is exactly the answer? Hi, Sagun. Hi, Beta. How are you? Now, listen here. Very simple answer. Try and understand this. Ki once the rope is exactly having stone tied on it and you are rotating like this, you know which direction it will go? It will take the tangential direction. So, if the rope will be exactly, the stone will be either moving in the tangential direction. Okay, it will be, good evening, Beta. It will be exactly going in the tangential direction. Okay. It will be going in which direction, beta? Tangential. Because the circular path has direction of motion. What the circular path is having? Direction of motion along the tangent at any point. It will have what direction, beta? Circular direction. The direction of motion will be along the tangent at any point of the circle. So what will happen? The stone will be exactly falling in any of the tangential direction. Now second question, beta, I am asking, why a cycle is having a mud guard, beta? Why a cycle is having a mud guard? You might have seen that cycles are having mud guard. What is the reason behind the cycles are having mud guard? It will protect from, you see, I'm cycling. Please, scalar quantity, please. I'll explain scalar quantity, beta. Just 1 minute, one question I have asked. If you can answer this question, the question is very simple, beta. That is Xavier. Can you answer, sir? Can you answer? You just tell me why the cycles are having mud guard. Sagun, correct answer. But why the cycles are having mud guard? You know that the cycles will be exactly, the paddles are like this. Okay. Now, when you will be allowing, the cycle will be exactly moving like this. So what will happen if this is a muddy area? If this is mud will be there, then what will happen? All the mud will go in tangential direction. So anyone, in fact, all the muds will exactly go in tangential direction. You thought of it? So it will be going in tangential direction. So whatever person will be in backside, they will definitely get this mud. Understood? Specifically in the rainy days. So what we are doing is we are applying the mud guard. So why we are applying the mud guard? So that, why we are applying the mud guard? We are applying the mud guard so that the muds will not be going on anyone's dress, because it will move tangential. It will move what direction, beta? It will move tangential. I hope you might have understood. So it will be exactly moving what beta? Tangential to protect the rider and the bicycle from mud guard and water. Absolutely correct beta. Absolutely correct. Now one question is there. Can I ask from you? One question is there. Listen. One question is there. Can I ask from you? Any one of you, if you can answer. The question is, in a rainy day, you know that you are putting mud guard on everything. In a rainy day, why people are falling so often? In a rainy day, why people are often falling? In a rainy day, why people are often falling beta? Anybody? Means often falling means you will be saying that cycle also you are exactly skidding. Sometimes in a rainy day you are skidding in the skidding with the cycle. What is the reason behind? But normal day skidding is not possible. Normal day very less amount of skidding will be there. When you will be little bit off guard, then only skidding is there. But in rainy days sometimes skidding is there. What is the reason behind it? Can you tell me? Does water increases the friction or water reduces the friction? The answer is water is reducing. Yes, because of wet and slippery surface, water. Yes, beta. Shreya, good evening, beta. So actually it is doing what, beta? It is reducing the friction. The friction reduction will allow the grip between the tire and the surface will be reduced. The grip between the tire and the surface will be reduced, and because of that only what will happen? Exactly, the cycles are slipping. I hope you might have understood. Come on, we will go for the next one. Now we are going to understand the most important thing, the scalar and the vector. Zevin has asked about scalar and vector. Amrish, can you answer what is the meaning between scalar and vector? But in physics, all the physical quantities are there. The physical quantities which are exactly there, they are categorized into two categories. Understood? One will be called as vector, another one will be called as scalar. What is the meaning of scalar? The meaning of scalar means exactly it will have only those physical quantities which are having only magnitude but no direction is considered as a scalar. Is considered as what beta? Scalar. And the one which will have magnitude and direction both will be considered as vector. Understood? The one which will be considered as both vector means the one which will have both magnitude and direction will be considered as what beta? Vector. And that's the crucial difference between this. I hope you might have understood this one. That's the crucial difference between a scalar and a vector quantity. I hope you might have understood this one. So if somebody will be asking you about scalar and vector physical quantities, you will be saying that the one which will have only magnitude will be considered as a scalar, and the one which will have magnitude and direction both will be considered as vector. I hope you might have understood this one. Come on, say children. Got it? What is the difference? So physical quantities like force is a vector quantity, momentum, linear momentum is also a vector quantity. Displacement is a vector quantity, acceleration is a vector quantity. But if somebody will be asking you about distance, we can say that distance is a scalar quantity. Distance is what? A scalar quantity. That's the main important thing we need to understand. Come on children, did you understood this one? So now we are going to go to the next point. So I think till here everyone clear? Crystal clear with the concept, please? Yes. So scalar quantity, I think Zevin might have understood. Now come on, we are going to go for momentum. Okay. So force is equal to mass into acceleration is there. But before that, we are going to type of inertia we have learned already. Mass, rubber ball, that contents also we have understood. So momentum is the quantity of motion a moving body has. It tells us how hard is to stop moving object. It depends upon two things, mass of the body and velocity of the body. Understood? Harihar uncle, Bihari mein job. What is that, beta? I did not understood. Now come on, let's check this one out. Numerical karaएं. Yes, I'm going to do the numericals only, but first I'm going to tell you about momentum. So momentum is equal to mass into velocity. But if any vehicle will have higher mass, then its velocity will be what? Velocity will be more or less. So I am going to take a ball and I'm going to take a stone. Okay. Now both will roll. Now which one will naturally stop? Huh? God bless you, beta. Huh? PT meme, mammy. Okay? Ball. So which one will be having, beta? Which one? Which one will naturally stop and which one will be exactly taking time to stop? Miss, which one will stop easily and which one will take time to stop? Huh? Oh, stone will stop easily. Come on. How many of you are present online are exactly having this? See, Neeraj, absolutely correct, beta. See, let's study. This channel, ball stop easily. Absolutely correct. The correct answer is the ball will stop easily. The correct answer will be the ball will be exactly stopped easily. Um, hello, beta. So ball will be exactly what? It is going to stop easily. Understood. Now next important point we are going to understand when we are writing momentum. बॉल क्या होता है? बॉल का मतलब बॉल होता है. क्रिकेट देखा है कभी बच्चे? So if you have seen cricket, you please check that one. Shall we check this one out, beta? My house is in Chennai. I am in Anupuram. Okay. Now look here, beta. हिंदी में घर चेन्नई में है, यहाँ पे है. झारखंड से हूँ, घर चेन्नई में है बेटा, अनुपुरम में. ओके चलो, शेल वी टॉक अबाउट स्टडीज. हम लोग पढ़ लेते हैं, उसके बाद वन डे वी विल कीप अ स्पेशल सेशन वेर आई विल टॉक मोर अबाउट माई सेल्फ. ओके नाउ लेट्स सी बेटा. अच्छा, कैन एनीबडी टेल मी व्हेन द मोमेंटम ऑफ अ बॉडी बी जीरो? ओके, हाय बेटा, हाय ऋषभ. व्हेन द मोमेंटम ऑफ अ बॉडी बी जीरो, कैन एनीबडी टेल मी व्हेन द मोमेंटम? Shall we start, beta? It's going very different. So I want to teach right now. Okay, I want to teach right now. Shall we go for my work, beta? So now we need to understand that momentum is equal to mass into velocity. So we need to get two things when we are writing momentum. Momentum is equal to mass into velocity. Now let's get back to the work. So when we are writing momentum, momentum is nothing but mass into velocity. So when a body will be having mass higher, its momentum will be more. When the body will be having velocity higher, its momentum will be more. Understood? That means what? So momentum is the product of mass into velocity. So if somebody will be asking you about momentum, you can directly say that momentum is exactly the product of mass into velocity. Okay. So when mass will be in higher side, its velocity will be exactly constant, then momentum will be high. आफ्टर दिस ओनली बेटा, फिजिक्स मॉर्निंग में है, नोट्स आर देयर, एक बार चेक कर लो आप. ठीक है. और अभी मैं लाइट पढ़ा रही हूँ, सारा रिवीजन वाला क्लासेस वहीं पे मिलेगा आपको. ठीक है. या आई एम गोइंग टू टीच टिश्यूज वन मोर टाइम. शांतनु, हिंदी में बता देती हूँ. मोमेंटम का मतलब क्या होता है? मास इनटू वेलोसिटी प्रोडक्ट. प्रोडक्ट मतलब जब आप मास और वेलोसिटी को मल्टीप्लाई करते हो तो वो क्या होगा? वो तुम्हारा मोमेंटम हो जाएगा. मोमेंटम का मतलब क्या होता है? एक मोशन जनरेट करना बॉडी के अंदर में. ठीक है. व्हाट इज द मीनिंग ऑफ मोमेंटम? Momentum is generation of motion in a body. Understood? So momentum is motion generation in a body. It totally depends upon mass into velocity. So now, is momentum a scalar quantity or a vector quantity? The correct answer is momentum is a vector quantity. Because in which direction motion will be generated. So now I'm not going to see the chat part. I'm going to start teaching to that level. Okay. So little interaction I will do. I will ask, I will immediately answer all the questions, but right now little of teaching I will do better. Okay. So now listen. So if I'm going to talk about momentum, if I will keep on discussing, but I'll not be able to teach the content. So I'll be discussing all the things, but one by one. Okay. Now listen, momentum is equal to mass into velocity. So if I will keep the velocity of both objects, so two things I'm going to take. Okay. Two things I'm going to take. I'm taking A and B object. Okay. Now what I am doing is I have taken mass m1 and m2. So A and two objects are there, and here mass of the first object is m1 and mass of the second object is m2. Now mass of first object is on higher side. Higher side means mass of the first object is more. Understood? But velocity, so when I released both the object to check whose momentum is more, what I did is, absolutely correct Neeraj, what I did is I kept their velocity same. The moment I kept their velocity same, what I am checking here is momentum is equal to momentum of first object, that is MA, and momentum of first one. Momentum of first one is m1v and momentum of second one will be equal to m2v. Now if I have to relate the momentum, so we know that it can be create a relation between both of them. Can we create a relation? So I am going to write, this is my equation 1 and this is my equation 2. Can we relate with the help of the velocity? So what we are going to do here is momentum of first one by mass is equal to V1. This is I have written from equation 1. From equation 1 I have taken this one. From equation 2 I am going to take, so momentum of second one is by m2 is equal to v. So if this one is equal to v and this one equal to v, that means what beta? I am going to connect both of them together, then it will become momentum of first one by m1 is equal to momentum of second one, because momentum of second one by m2. Now mass of first one is on a higher side. Mass of first one is on a higher side. I told you now that first object mass is more. So will the momentum of first one be more? Yes, so if I am going to write momentum of first one with respect to second one, m1 by m2, directly we can relate it. Understood? So if I am going to create a relation, I will be getting a solid answer, and the answer is if the mass of a body is more, its momentum will also be more. So between two objects here, if mass of the first object is more, then its momentum will also become more. Its momentum will also become more. Give me. So if mass is more, what will be more? Momentum will be more. Got it? So mass more means momentum more. Can you tell me what is the SI unit of momentum? Is momentum a vector or a scalar quantity? So we will say that a momentum is a vector quantity because its direction is the same. So mass is directly proportional to momentum. Mass is not directly proportional. Momentum is directly proportional to mass, and momentum is directly proportional to velocity. That's what beta we can say, and constant value will be there. So momentum means if mass will increase, momentum will increase. If velocity will increase, momentum will increase. If mass will increase, momentum will increase, and if velocity will increase means momentum will increase. So what is the SI unit of momentum beta? Since momentum is equal to mass into velocity. The unit of mass is kg. The unit of velocity is meter per second. So what is the unit of momentum? Kg meter per second. Absolutely. The unit of momentum is kg meter per second. The unit of momentum is kg meter per second. Last time again I am asking, the linear momentum is a scalar quantity or a vector quantity. If it is a scalar quantity, y. If it is a vector quantity, y. Is it a scalar quantity or a vector quantity? Is it a scalar quantity or a vector quantity? ऋषभ कमेंट बॉक्स पे क्वेश्चन डाल दो. Just put the question in the comment box. In the time of teaching physics class, at the time of teaching in physics class, I will solve and send you. Okay. It is a vector quantity. Why, beta? Because the velocity is in velocity. The body is moving in a particular direction with certain velocity. The body is moving in a particular direction with certain velocity, and that time, beta, what will happen? It will be considered as a vector because the motion of the body will be that direction only where the velocity is exactly going. I hope you might have understood. Yes, beta. You put in the comment box, beta. I will solve it. Okay. Now we will be going vector of which momentum depends. Now we have understood the second. Now one question I am asking you, please answer this question. If the mass of a body is doubled and its velocity remains the same, what will be the change in the momentum? My question is, if the mass of a body is doubled, Mosque, hi. If the mass of a body is doubled, come on, start solving, please. If the mass of a body is doubled, I repeat, if the mass of a body is doubled and its velocity, Shreyans, good evening, beta. Thank you, Mosque. See, the mass of a body is doubled. What will be its momentum when velocity remains the same? The correct answer is what, beta? Maths class होगा बेटा. Momentum is doubled. Absolutely correct. The momentum will be doubled because from the usual part, because if mass will be doubled, its momentum will also be doubled. Its mass is doubled means its momentum will also be doubled. So momentum is equal to mass into velocity. Now what happened, beta? A new momentum. What will be the new momentum if now mass is exactly 2 times of the original mass? So the mass is exactly now the new mass is 2 times of the new mass is 2 times of the original mass. The moment we will be writing like that, hi Rahul, the moment we will be writing like that, the momentum will exactly also become double. The momentum will also become double. I hope you might have understood. First, you go to the live part because the students are giving answer very, very late. So you need to press the red button and you, Shreyans, yes, beta, maths class is different timing. All the classes are having different timing. So if it is possible, you can go for it. थोड़ा पढ़ ले, बाद में पागल पागल गेम खेलेंगे. ओके, थोड़ा सा पढ़ लेते हैं, फिर पागल पागल तो सभी पागल है. Come on. Okay, if I will reduce the velocity keeping the mass same. Hi Rahul, if I will keep the mass same and I will reduce the velocity by half, what will happen to the momentum? What will happen to the momentum? What will happen to the momentum? Can you say, beta? If, see, because here I have discussed this part, I'm just discussing a simple part here. Ma'am, they are disturbing here. Seriously, today disturbance is more. Now listen, what we are going to do here is, we will keep the mass same, okay, and we are reducing the velocity. So usual velocity is v, and when we are, just check this one out. So usual velocity is v. We know that momentum is equal to mass into velocity. Okay. Now what we have done here is, we are reducing the velocity. So new velocity is half of the original velocity. Done. So beta, now what we are going to write, this will go there and it will become 2 of Vn is equal to V. So now what will be the change in the momentum? So what will be the change in the momentum? The momentum will become also half. The momentum will become also half. So if we are generating a relation, the momentum momentum will also become half. Just please remember this part. The momentum will be half. Chalo, we'll start the numerical. Children, come on. We are going to solve the first numerical based on momentum. Absolutely. So if velocity is 3 times, what will happen to momentum? 3 times. If mass is 3 times, if mass increases to 10 times, understood? Now, if the mass will be reduced to half, okay, Rishabh, you read better. Once I will start that session, I will be exactly informing you. Huh? Just send the link, just send the question in the what you call comment box. I will solve and keep there. I hope you might have understood there. Mass 3 times. Momentum will become 3 times because we know that momentum is directly proportional to mass and it is also directly proportional to velocity. I hope you might have understood till here. Now we will be talking about our work. Write the first question. Find the change in, write the first question, easy question. First we will start with. Let's start the question. Very, very easy question. What is the momentum of a body? What is the momentum of a body? What is the momentum of a body of mass 42 kg having a velocity 3 meter per second? Come on, beta. This is just the simplest question. This is just the simplest question. You go for the live part. Otherwise, you are answering the wrong answer, beta. Come on, go for it. Come on, go for it, children. Shreyans? कोई problem नहीं बेटा. I'm not talking about number. Always the number is not important, beta. Gokul. What is the answer is that is equal to mass into velocity. Mass is 42, velocity is 3. How much it is coming? 6. 126 kg meter per second. 126 kg meter per second. Okay. 126 kg meter per second. बेटा पढ़ाने को तो एक स्टूडेंट ही मत पढ़ाओ. नो, एक भी काफ़ी है बेटा, एक भी काफ़ी है. तुम ही काफ़ी हो, तुम ही पढ़ लो. Okay. Now listen, beta. Done. Now write the question. Write next question. Find the change in momentum. Just write the question, beta. Find the change in momentum. Understood. Find the change in momentum. 126 correct hai beta. Find the change in momentum of a car whose weight is weighing how much it is? 1500 kg. Understood? When its speed increases, absolutely correct, beta Shreyans. When its speed increases, from 36 kilometer per hour to 36 kilometer per hour to 72 kilometer per hour. Understood, beta? So speed will be increasing from 36 kilometer to 72 kilometer per hour. Understood? Yes, you have to change because here now you need to understand one thing. The velocity is given in kilometer per hour. We need to convert it into, I am from Chennai, beta. We need to convert it into meter per second. We need to convert it into meter per second. And most of the students अभी offline mode में भी पढ़ रहे हैं और online mode में भी पढ़ रहे हैं. Yes, but you, after that you have to write the change in momentum. Now, what is the formula for change in momentum, beta? Final momentum minus initial momentum. Yes, you have to find the change in momentum now, because mass remains the same. Mass of the body remains the same. Mass of the body beta remains the same. So first we will be talking about the initial velocity. The speed is exactly increasing 36. So 36 into what we are going to write? 5 by 18 meter per second. 5 by 18 meter per second. It will directly get converted into meter per second beta. So here 3 ones are 3, 3 twos are 6, 3 6 are 18, 2. How much it is coming? 10 meter per second. This is the initial speed. Now beta, what will be the final speed? We are going to check this one out. 72 into 5 by 18. Then what we are going to do? 6 ones are 6, 6 twos are 12, 6 threes are 18, 4. So how much it is exactly coming beta? It is coming as 20, directly 20 meter per second. So change in momentum. So if somebody will be asking you what is the change in momentum, so change in momentum is equal to final momentum minus initial momentum. Understood? So what is our final momentum beta? Mass remains the same. So here m into v minus m into u. What is our, we will take m common, v minus u. What is our m? What is the weight beta? It is exactly coming as 1500. And what is v beta? 20 minus 10. So how much it will come? 1500 into 10. So it is coming 15,000 kg meter. So let's see how many of you have given answer. Bhavya, absolutely correct. First answer is given by Arunisha. After that, Neeraj has given the answer. After that, Bhavya has given the answer. Super beta. God bless you all. So that's what is called as dedication. It's not about the number. It's about how you are attempting a question. Understood? So now we have understood what is momentum. Now, can momentum be decreased? We're always talking about increase in momentum. Can momentum be decreased? Can you answer this question, please? Can momentum be decreased? We discussed about change in momentum. So momentum is increasing. Can momentum be decreased? Yes, Neeraj, absolutely correct, beta. When, when, when? Can momentum be increased or decreased? Your perfect answer will be by reducing mass or velocity. By reducing mass or velocity. Neeraj, understand one thing. I just I just need to understand one question. Just understand one thing, beta. When we are having a specific velocity, I am exactly an object right now. I am having a specific velocity, okay, and I am having a specific mass. So first, my mass will not change. The mass of a body remains constant everywhere. First, technicalities understand. The mass of a body remains constant everywhere. Done? So I cannot change the mass. Understood? I can compare only one thing. I can compare, understood na Neeraj? I can compare only the velocity. Understood? So how can I reduce momentum? Can you tell me? How can I reduce momentum? Absolutely correct, Neeraj. He got the correct point. I can't change the mass of a body now. Suddenly, car mass means a body specific having a specific mass. I can't change the mass of a body. The body will have a mass. According to it, it will have a momentum. Understood? Now I can double the mass of the body. Like a car is there. Today it is a vacant car. Good evening, beta Arman. Today it is a vacant car. So the car is moving. Tomorrow I am going to add 4 5 passengers in that car. So definitely addition of passengers will increase mass. Correct, na? So that is called as increment of mass. But that is a different thing. Good evening, Arman. Yes. So my question is, bless you, beta. So Arman, bless you. Now listen and understand. Huh. Huh. So here you need to understand one thing. We can't change your understanding mass of a body for a specific motion. Once the motion is started, we can't change. Remember this one. Remember this part. Bless you, beta. I'm trying my level best. So once the motion of a body started, I'll explain your doubt, beta. I'm just in between a statement. Let me finish the statement. So once the motion of a body is started, we can't change the mass. What can be changed is its velocity. Now, if the body is in contact with the surface, the friction will oppose the motion. After some time, because if there is an external force, the external force will let the body stop after some time. Correct, na? Because the external force is exactly letting the body move or letting the body stop. Got it? So it can either be letting the body go in a forward direction or letting the body go in the opposing direction. Got it? But friction will exactly work in an opposing direction and friction will stop the motion. So velocity will, if there is no driving force, again and again, then the body will be internal driving force. If not there, the body will come to rest. At that time, the momentum will be slowly going down. Understood? Yes, Yogita, you can ask. That time, okay, reduce in speed. Absolutely correct, beta. It will be reducing in speed. It will be reducing in speed. At that time, the same thing, one question will be asked. At that time, change in momentum will become reducing one. So answer will come in minus. Force is a vector quantity. Yes, beta, force is a vector quantity. Arman, now you can ask. Now, I hope you might have understood. Did you understood this part, beta? Momentum we have discussed. Now we are going to talk about force. Now first, children, quickly start answering the question. Right, right now, beta, I want to remind everybody one thing. I'm teaching class 9th. When morning time is 10th class, evening time. What is force? Force is mass into acceleration, beta. So when we will be talking about force, now we are going to start force only because we have just discussed about momentum. Understood? Rate of change of momentum. Rate of change of momentum. I'm just telling about mass, force. Okay, momentum is a vector quantity. Yes, beta. Now only you are telling, I think it is surfing more, less. So I'm going to talk about force. What is force, beta? Product of mass into acceleration. Okay. Now I want to formulate Newton's second law of motion. What is our Newton's second law of motion? I'm seeing your comment box. Please kindly say what is Newton's second law of motion. Come on, go for it. Newton's second law of motion is exactly tell about force. What is force? The rate of change of linear momentum of a body is directly proportional to the applied force. I repeat, the rate of change of linear momentum of a body is directly proportional to the applied force and takes place in direction in which the force acts. And it is taking place in the direction in which the force is acting. So this is exactly what, beta? Newton's second law of motion. Now is the video blur? Now come on, say. Is the video blur? Now come on. Now is it okay now? What is force? What is force? Then you will be saying, auntie, force is mass into. Okay, very good. Gawar, very nice, super, super, very good, beta. Top. So now we will talk about linear momentum. Linear momentum, we will be starting with what? Initial one and the final one. So what is our initial linear momentum and what will be our final linear momentum? So if we will be talking about linear momentum, initial linear momentum we will be taking as m into u. Okay, so this will be considered as initial linear momentum. m into u. Okay, now when we are going to talk about final linear momentum will be what, beta? So we will be talking about final linear momentum. So what is final linear momentum? M into v. Okay, थैंक यू सो मच. आई एम डूइंग PhD इन मैथमेटिक्स. उसके बाद बोलना, ठीक है? एक बार आ जाओ, उसके बाद पता चल जाएगा. सो उसके बाद हम बात करेंगे. अभी बात नहीं कर सकते. सो चेंज इन मोमेंटम विल बी व्हाट बेटा? So if somebody will be asking you about change in momentum, then change in momentum is final momentum minus initial momentum. So change in momentum will be what beta? Final momentum minus initial momentum. This is only considered as change in momentum. But beta change in time कैसे लेंगे? चेंज इन टाइम कैसे लेंगे? नेट मोमेंटम. दैट्स व्हाट बेटा. चेंज इन मोमेंटम वी हैव टेकन. नाउ वी आर गोइंग टू टॉक अबाउट रेट of change of momentum. Now rate of change of momentum, when we are talking about rate of change of momentum, that time will be applicable, because how can we come to know that the body momentum is exactly increasing or decreasing? So first we need to talk about rate of change of momentum. In that, time is one of the most crucial thing. How can we come to know that right now I am this much kilometer I am covering and this much kilometer after some time? Why? Because auntie, I have started this time at time t is equal to 0. I have this much speed. Now after some time I am having this much speed. That means what? Time is one of the crucial part. Time is one of the crucial part. So if time is one of the crucial part, means any type of motion is under the frame of time. Any type of motion is under the frame of time. So change of momentum, whenever we will be talking about that time, we will be exactly correlating the momentum with time. Understood? So what we are going to write there, beta? That time we are going to take as rate of change of momentum. This is change of momentum. This is nothing but change of momentum. But when the momentum will change, when momentum is changing, momentum is exactly coming with time. Time is one of the crucial thing. Yes, what is v and u? V is considered as final velocity and u will be considered as initial velocity, beta. So whenever we are talking about final velocity and initial velocity, that is exactly the change in velocity. And when the velocity will change, when the velocity will be changing, the velocity will be changing with time. So time is one of the most crucial factor. Okay, हिंदी आता है और तुमसे बहुत अच्छे से आता है, ठीक है? Now look here. So here when we are going to talk about rate of change of momentum, rate of change of momentum. So when we will be talking about rate of change of momentum, means change in momentum by time taken. So it will become change in momentum by time taken. Understood, beta? So rate of change of momentum means change in momentum by time taken. So change in momentum will become what, beta? mv minus mu by t. So if we will take m common, it will become v minus u by t. We did nothing. Till here, whatever we did, we were just talking about momentum. And you know what? Newton said a very simple thing. Newton said that rate of change of momentum is directly proportional to what? The force. Got it? Because technicalities are saying that when a body is having some velocity, when it will be having velocity, when it will be having mass. So according to the mass, the body will have its higher velocity side or lower. Because if heavier body will be there, like a very big stone is there, it will be difficult to stop the stone. But a very small ball will be there, you will be exactly able to stop the ball. I hope you might have understood, Arman. So we can understand about momentum. So Newton concept is exactly about rate of change of momentum is directly proportional to what, beta? Rate of change of momentum is directly proportional to, say, force. Applied force. Applied force where? Applied force where? in the direction where the force is acting. Now, in simple way, what we can say here is the body is moving here. So now initial velocity of the body was u. The mass of the body is m. After some time, mass remains the same. Now this is exactly considered as final velocity. Okay. Now here the time taken is considered as t. So what is the change in momentum, beta? The change in momentum, this is initial one. So initial momentum we will be written as initial momentum m into u. And what is the final momentum, beta? Final momentum is m into v. So change in momentum. So change in momentum will be mv minus mu. Now rate of change of momentum. Okay. Rate of change of momentum means mv minus mu by t. Now beta, understood everyone? Come on, focus Arman, focus in study beta. So now look here, rate of change of momentum m will be equal to v minus u by t. And beta, we directly understand one thing here. Here one thing must understand in a simple technique. Now this is exactly rate of change of momentum we are going to now talk about. Now where is force? Newton said a very important thing. This part, whatever rate of change of momentum is there, what we have generated is directly proportional to force. So no, we will not be talking about anything. We will be just talking about mv minus u by t directly proportional to force. Understood? So it becomes a absolutely by equation of motion, absolute answer because of initial. So beta, we generated this one, rate of change of momentum mv minus u by t is directly proportional to force. Understood? And this force is in the direction of motion of the body. Understood? So only I asked you one question. You might have remembered I asked you one question that beta, will the momentum be decreased? Will the momentum be increased? That time you have said yes. And now beta, we will do only one word. See, this is called as proportionality. This is what beta? Proportionality. Proportionality is never equal. To bring proportionality into equality, we will have to put constant of proportionality. What we have to put? Constant of proportionality. So F will be equal to K M V minus U by T. And beta, by equation of motion, we know that A is equal to V minus U by T. So F is equal to K M A. Bingo. But beta, what will be the value of K? What will be the value of K? What is the value of constant of proportionality? When force will be 1 unit, okay, when force will be exactly coming as 1 Newton, okay, K will be considered as 1, absolutely correct, because mass we will take as 1 kg, acceleration will be taken as 1 meter per second square, and force will be considered as 1, so K value will be coming as 1, so 100% F is equal to ma, and this is the force formula. Force is equal to mass into acceleration. Force is equal to mass into acceleration. Today too much disturbance was there, and again some unwanted things were there. So tomorrow seriously I'm going to keep the comment section off, and I'm going to teach, because I'm here standing to teach. I'm not here to answer your questions. Okay. I am keeping the comment section on because my children need some conclusive answers, and when they're asking any question, I'm giving. So I hope if you are really wanting to study, and one thing I want to answer, why I am not teaching in Hindi. I can teach in Hindi very well. Problem here is I am in South and most of the children is understanding in English. I don't know Tamil. Okay, and because of that only. So, and we know that we are in CBSE. We have studied in CBSE. So better we should communicate in English so that, see, I can communicate. Okay. I hope everybody might have understood here, beta. Come on, children. Say, did you understood? Got it? So K value is coming as 1. So we have just understood Newton concept. Then you have to learn. We have to learn to exist in every environment, beta. हिंदी कर लेंगे, इंग्लिश में भी करके दिखाना है, ठीक है? So I hope everybody understood. Come on. Newton's second law of motion is rate of change of momentum is directly proportional to force in the field of application. Understood? So force is directly proportional to m v minus u by t. And v minus u by t is nothing but a. So constant of proportionality, if I want to remove, what I am going to put there? K. And k is constant of proportionality. And what is the value of k? Come on children, before going, tell me. What is the value of k? The value of k is taken as 1. Next class we are going to solve. So force is a scalar quantity or a vector quantity? Force is a vector quantity. Okay, bingo. How to learn English? Try. Vector, absolutely correct beta. And can I tell you one thing? एक बात बोलूं, लड़ो और सीखो. कभी कभी ऐसा होता है कि हम कोशिश नहीं करते. मैं भी तुम में से एक ही थी. हिंदी से ज़्यादा मुझे कुछ नहीं आता था. खुद को कॉलेज के लेवल पे लेके आई और मैथ्स में टॉप किया. अंडरस्टूड? गॉट इट? बाय एवरीवन.